Hey, what's up, pre-calculus students? This video is going to go over the first page of the 2.5 Part 2 notes. So we will be talking about rational functions and limits at infinity. So just to review from last time, the limit laws for limits at infinity, if c is a constant, then the limit of c as x approaches negative infinity would just remain c. And the limit of c as x approaches positive infinity would remain at c as well. So when you have a constant function, something like, let's say, y equals 2, the limit as x goes to either positive or negative infinity of that constant function y equals 2 would just be 2, because the y values do not change on a constant function. So as x goes to negative infinity, your y is always at 2. And as x goes to positive infinity, your y is also at 2. All right, and then we have if f of x is equal to c over x to the n power, c is a constant, so that is important. And the value of n is greater than 0, meaning the exponent has to be some kind of positive number, then both of these limits will be equal in value to 0. So we discussed that last time in the lead up to this lesson, and I am just reminding you of these facts. So in problems 1, 2, and 3, we want to figure out what these limits come out to. So we have the limit as x goes to infinity of this fraction function. And one thing we can do is just take the highest power of the x in both the numerator and the denominator. So we're really just focusing on this limit. And since x squared divided by x squared is 1, that's going to change this into the limit as x goes to infinity of 3. Now 3 is a constant, and as x goes to infinity, the value of that constant will not change. So the answer to this problem would just be 3. So that means the limit of this function as x goes to infinity would just be 3. Okay, moving on to number 2. So again, we have the limit of a rational function. So we can just take the terms with the highest exponent from both the numerator and the denominator. So that would be 3x cubed in the top and x to the 5th in the bottom. So now we could try to simplify that fraction and see what we get. That would leave us with the limit as x goes to negative infinity of 3 over x squared. Now this limit is of the form of the second limit law. So my numerator is a constant and my exponent is something higher than 0. So no matter whether we're going to negative infinity for x or positive infinity for x, the value of that limit would just be 0. Okay, so that brings us to our next example. Why don't you pause the video, see if you can write it out the way we have been, and we will talk about it in a second. Okay, welcome back, everybody. So the limit of this function would be equivalent to the limit as x goes to negative infinity of just x cubed over x, and that'll simplify to x squared. So now we want to ask ourselves, what's the limit as x goes to negative infinity of x squared? Now, since this is just a power function at this point, the exponent is even and the leading coefficient is positive 1, we can think of this as a power function where both ends point up to the sky. So the limit as x goes to negative infinity of x squared, we'll be talking about the left end here, and that would be approaching positive infinity, which is our final answer. So that means the limit of this function as x goes to negative infinity would have to be positive infinity. Okay, the last thing I'm going to touch upon in this video is the concept of a horizontal asymptote. So a horizontal line that the ends of a function approach but never touch is what we call a horizontal asymptote. So in terms of limits, if we have the limit of a function f of x as x goes to negative infinity equaling c, or the limit of that function as x goes to positive infinity also equaling c, then we could say that the line y equals c is a horizontal asymptote for that function. So the horizontal asymptote equation is determined by the end behavior limits of our function. So I didn't give us an equation for any of these graphs. We're just going to look at it and try to answer each of the following questions. So I will do the first one with you, and then hopefully you can figure out the other two on your own. So the first question is saying, what's the limit of this function as x goes to negative infinity? So if we just highlight the left end of the graph, we can see that it's leveling out towards that dashed horizontal line. So that means the limit of the function as x goes to negative infinity would just be a value of positive 2. Now, if I do the limit of the same function as x goes to positive infinity, we're just looking at the right end of the function. And again, the right end is getting closer and closer and closer to that dashed line. So we could say the value of that limit is 2 as well. And for that reason, because these end behavior limits are equal in value to 2, that means this graph has a horizontal asymptote of y equals 2. So I'd like you to pause the video and try the next one on your own, and we will go over it in a second. Okay, welcome back, everybody. So I highlighted the two ends of the graph, and if we look at the left end, we can see that it's getting closer and closer and closer to the x-axis. And since the equation of the x-axis is y equals 0, I could say that that left end limit, or the limit of the function as x goes to negative infinity, would just equal 0. Now when we look at the right end, same thing's happening. The curve is getting closer and closer and closer to the x-axis. The equation of the x-axis is y equals 0. So that means this limit would be equal in value to 0 as well. So what that tells us is that our function has a horizontal asymptote of y equals 0. Now don't get alarmed that this middle curve passes through the horizontal asymptote. The horizontal asymptote is just the line that the function gets close to on the ends of the graph. So if it crosses it in the middle, no big deal. It's just each end will get closer and closer and closer to it without ever touching it. All right, why don't you pause the video, see if you can just do the last one on your own, and we'll check it out in a second. All right, welcome back, y'all. Let's take a look. So I highlighted each end of the graph. So on the left end, as as x approaches negative infinity, the f of x values get closer and closer and closer to this dashed line. And the equation of that dashed line is y equals 1. So that limit would be positive 1. Now for the right end, the limit of the function as x goes to positive infinity would equal negative 1, because the far right end of this function is approaching this other dashed horizontal line. And since the equation of that horizontal line is y equals negative 1, that means this limit's value would also be negative 1. So the end behavior limits tell us about the horizontal asymptote on the graph of our function. And it's okay to have two different horizontal asymptotes. And we can see that is the case here. All right, guys, that wraps it up for this video. If you have any questions, let me know. If not, we will just finish this up next time I see you. And that's it for me. Toodles.